So in this one we have a non-uniform rod, so it means the mass does not act in the middle of this rod. The magnitude of the force acting at rod at D is twice at C. So if we think of our reactional force, we have 2R at D and 1R at C. And then the centre of mass of the rod is D meters from A. So we want to go from A, and this is going to be D meters. So here I'll put the mass, which is capital M, G. So first thing I can say is that R plus 2R equals mg, or 3R equals mg. Now what I'm going to do next is take moments about C. Now if I'm looking at this about C and want this distance, which is D minus 2.5, so we get D minus 2.5 multiplied by mg. That's going in one direction. And then for the other one, we need to work out this distance between C and D. And this distance is 4.5, because the total distance has to add up to 9. So we know that 2R times my 4.5 is then going in the other direction. Now then, let's call this equation 1 and equation 2. Now from 1, R is going to be 1/3 mg. And I'm going to substitute that into 2. So we get 2 times 1/3 mg times this 4.5. Now I can divide by m, and then those will cancel, and g is obviously 9.8. So from here now it's a matter of expanding. Oh, actually I can divide by g as well. That'll be easier, won't it? Now it's a matter of expanding and simplifying. So we get d minus 2.5 equals 2/3 times my 4.5. So d equals 5.5 meters. So it's 5.5 meters from A. You could have taken moments about D as well. That would be an alternative way. But it's easier to take them from C because it's easier, I think, for the D to explain. So for these kind of questions, think about sketching out what's happening first. So we have a particle of mass 2m, and it's moving on a rough horizontal plane, and it collides directly with a particle Q of mass 4m. So there's my Q, there's my P. Just before the collision, P was moving at 3u speed, and Q is at rest. So this is the before. Then let's look at the after. After, we know that Q is moving at 2u. It doesn't tell us anything about P at that point. Now, momentum before is going to equal momentum afterwards. So we get 2m times 3u plus 4m times 0, and that equals 2m times v, which we want to find, plus 4m times 2u. So let's sort this out. So we get 6mu on the left, and then 2mv plus 8mu on the right. So if I rearrange, we get 2mv equals negative 2mu. And you can see that here we can cancel the m's, cancel the u's, sorry, the 2's. So v is equal to minus u. So the speed is minus u. Or the speed is u and it's going in the opposite direction. Since it does ask for speed, it's worth putting it down. Speed is u. Okay, because it's not talking about direction, just speed. So that means u is actually going in this direction. So for part B, state clearly the direction of motion of P, opposite direction. That's what you want to say, or opposite to its original direction. So I like to always draw a sketch about what's happening. I also want to put in my normal reaction here. So R is going to equal that 4mg. I've got my distance and what's happening. Now friction must be acting in this direction. So my friction is going to be mu R. So it's mu times 4mg. And this friction is the only force acting on it. So I'm just going to keep it as an F. Now we also know that that force can be written as F equals ma. And what I want to do is I want to find out this acceleration or deceleration is what I should be getting. So let's think about what we've got. We've got u, which is 2u. We've got v, which is 0. We want to find a, and we know the distance 6u squared over g. So what we can use is v squared equals u squared plus 2as, and that will be able to find us what a is. So we pop it up here. So we've got 0 squared equals 2u squared plus 2a, and then s is 6u squared over g. So that gives me 12 au squared over g, and equaling to negative 4u squared. Now I can see that I can cancel my u squareds by dividing through by u squared. I want to multiply by g and divide by 4. So a is equal to negative 4g over 12. And of course I can cancel this. So a is negative g over 3, which we know is just a number. Now I'm coming back to my F equals ma. But what I've got to think about is what's happening with this acceleration first before I make a mistake. So acceleration is obviously acting to the left. And if I'm talking about my F equals ma also acting to the left, because that is the only force on it, then a would be positive. Okay, so that is one thing I want to think about. So a is actually going to be g over 3, because we're looking at it acting to the left. So F equals 4m for my mass times g over 3. And then this F and this F have got to be equal. So we get 4m g over 3 equals mu times 4mg. So my 4's will cancel and my m's will cancel, my g's will cancel, so mu equals 1/3. And that's the question done. There should be more than one way of doing this. This is just happens to be the way that I did it. Okay, for A, let's think of again, I'm just going to do a very, very quick sketch. A car moving at constant velocity of 25 meters per second. That's at time t equals 0. And it's at point A. And 48 meters ahead, he sees a sign. So here we have first model, uniform deceleration of 6 meters per second squared until he reaches it. So now we need to find the speed of the car as it reaches the sign. So think about what we have. We have u equals 25. We have a equals minus 6. We want to find v, and we have the distance s. So what links them all together? V squared equals u squared plus 2as. So v, as we said, we're trying to find, and we got 25 squared plus 2 lots of negative 6 times 48. So that's 625 minus 576. And that gives me 49. So v has got to be 7 meters per second there. Now, in part B, it says that the car is assumed to decelerate until it reaches 13 meters per second, then maintain this speed. So if I'm thinking about that, v will be my 13, and I want to think about that distance s. We need to find the total time, but let's work out that distance first, as we'll need that final distance to find the final section of time. So let's find that distance. Now what links these again? It's obviously the same formula. This time we know what v is. So just rearranging, we get 12s equals 456, and dividing by 12, we get the distance is 38 meters. So if I think to my diagram now, I'm traveling 38 meters when I'm decelerating, and then the final 10 meters is going to be at that constant speed. So let's look at the time that it took to do this first section. So what links u, a, v and t? So v equals u plus a t. V we know is 13, u was 25, a was negative 6, and that's then times by t. So we get 6t equals 12, so t equals 2 seconds. So that's that first section. Now the second section, we can just use speed equals distance divided by time. Therefore time is going to be my distance over my speed. Now the distance we've got left is 10 and the speed is 13, so we just got 10 divided by 13, or I can put that as a decimal as 0.769. So I'll put this bit in black because I don't have a lot of room, but my total time is 2 10/13 of a second, or 2.769 seconds. Okay, either one would be acceptable there. So part C, the car moves for 0.2 seconds and then starts decelerating. So we're going to need to find this distance here. But we know what happens when it decelerates from 25 to 13. We know that that is over 38 meters, and we know that that takes us 2 seconds exactly. Don't make the mistake of thinking it takes the 2 and 10 over 13, because the 10 over 13, remember, was the last section in the last question. And if I add that time onto my 0.2, and if I added that time on, I could see that at this point it's taken 2.2 seconds. So looking at the first section, distance is going to be equal to speed times time. So it's 25 times 0.2, and that will be 5 meters. So I know that first section there is 5 meters. That means I know that the total distance travelled so far will be 43 meters, which means that that final distance here will also be 5 meters. So the time in my final distance, or my final little section, is distance over speed. The distance is 5 and the speed is 13. So my total time is essentially my 0.2 plus 2 plus 5 over 13. If I think of each of the 3 sections separately, that gives me a total time of 168 over 65 on your calculator, give you, or you can have 238 over 65, or in terms of decimals, 2.58 seconds. I'm doing this to 3 significant figures. Okay, so for part A here, we know that t is 2, so r equals 2 minus 3i plus 1 minus 2 lots of 2j. So our r equals negative I minus 3j. So think about how that looks. So minus I is to the left and minus 3j is down. So we've got something like this. This is in the direction of I. This would be in the direction of j. So we need to find this angle, and this is obviously R. And we want the angle between R and j. Now remember that this is also just a right angle triangle, isn't it? With a horizontal distance of 1 and vertical distance of 3. So let's call this one alpha. And I can see that we've got tan alpha is opposite over adjacent. So that means that alpha is 71.565 so on degrees there. If I look at my diagram, because of that right angle would be here, so our overall angle that we want to find, which I'll pop on the diagram in green here, this overall angle, we'll call that one theta. So theta is 90 plus my alpha. So it's 161.565 and so on, or 162 degrees to 3 significant figures there, or the nearest degree, isn't it? Sorry, which is the question asked you anyway. Now, for part B, what I'd think about is what my vector might look like. Now, we don't actually know because of the t's involved, so let's just draw a vector with its horizontal and its vertical. So it's t minus 3 and 1 minus 2t. And in this case, that's a right angle, but that distance here has got to be 2.5. Now, I should get more than one answer for t here, because this 2.5 should be able to be in more than one direction from this origin. But it's a right angle triangle, so we want just Pythagoras. So t minus 3 squared plus 1 minus 2t squared has got to be equal to 2.5 squared. So expand my brackets, t squared minus 6t plus 9 plus 1 minus 4t plus 4t squared equals, and let's write this as a fraction, 25 over 4. Now what I'm going to do is I'm going to simplify everything on the left, and then we'll work out probably multiplying by 4. But we've got 5t squared minus 10t plus 10 equals 25 over 4. So let's multiply by 4, 20t squared minus 40t plus 40. And this equals, of course, 25. 20t squared minus 40t plus 15 equals 0. Divide everything by 5 here. So we get 4t squared minus 8t plus 3 equals 0. Of course, you can do this a number of ways and using your calculator, but you just want to get to a point where you could A, factorize it, or B, use the quadratic formula. This one, b squared minus 4ac, you can see that this is going to be able to be factorized. Has to be a 1 and a 3 here. It's going to be 2t and 2t. Both are negative. Just double check. 4t squared minus 6t minus 2t is minus 8t plus 1. So we get t equals a half, or t equals 3 over 2. So there are my two possible answers for t. So we know tan alpha is 4 over 3. So I'm just going to pop that on my diagram. 4, 3, and that would be 5. I can use that then to be able to find my sine of alpha and my cos of alpha. So for example, sine of alpha is opposite over hypotenuse, and cos alpha is adjacent over hypotenuse. So I've got nice fractions for that. So let's again, look at the diagram. So we've got our alpha. This coming down here is 0.2 g from my 0.2 kilograms, isn't it? The thrust in the rod should be acting in that direction, and there is some form of friction as well. Now you can do this in more than one way. You can look at what T cos alpha is, give you an idea straight away which way friction will act, or you could take a guess at which way friction is acting in this case, and obviously, if you have a change in sign, then it's not going to be in that direction. So for part A here, I'm just going to resolve vertically. So going up, I've got F plus T cos alpha equals 0.2 g. We've got T is 2.5. And we know cos alpha is 3/5. So F is equal to 0.2 g minus 2.5 times 3/5. And that will give me 0.46 newtons. So I can say that, my friction, or frictional force, of 0.46 newtons acting upwards. Obviously, if my answer had come out negative here, it would have been acting downwards. Now, for part B, we're going to need to be able to use F equals mu R. So we need to find this normal reaction. So if I go back to my diagram, again, I'm just going to draw a very, very quick diagram here. R is going to come out here at 90 degrees, isn't it? So this is going to be t sine alpha. Okay, sorry. This is going to be r. This direction is going to be t sine alpha. So we can see that resolving, horizontally, we get r equals to t sine alpha. The greatest possible value of t is 6.125. So r equals 6.125 times, and sine alpha is 4/5. And that gives me that r is 4.9 newtons. Now, we also need to think about resolving vertically. If I look at my diagram again, we've got t and we've got alpha. We've obviously got the 0.2 g from the mass. Now, this is the greatest possible value. Don't forget, this is still in equilibrium. That's what the question says, is held in equilibrium. So if this is going to be the greatest value and it's going to be wanting to push this bead up, for this to be the greatest possible value, the friction must be acting in the opposite direction. So I'm going to pop that on in red. So we should also have the friction acting down this time. So resolving vertically, we would have t cos alpha equals friction plus 0.2 g. T is 6.125. Cos alpha is 3/5. F is mu r, which we know what r is, and we got our 0.2 g. So we want mu here, so we've got the 6.125 times 3/5 minus 0.2 g and divide by r. And that gives me 7/20 or 0.35 in terms of decimals. Now, for part A here, we can see at the beginning, which is this point here, the ball is thrown vertically upwards with this speed. After 2.5 seconds, it's going to reach its maximum height, and then eventually it hits the ground at 7 seconds. So if I just think of a kind of sketch, something like this, the ball's being thrown upwards, and then it goes all the way down like that. So the time taken to go from here to here is 2.5 seconds. Okay, which is, since the total time is 7 seconds, this time here will be 4.5 seconds. Okay, at this top bit, the velocity is 0. So let's first just look at this first section. So we're just looking at this section to the peak. So this part, t equals 2.5. U we don't know, but we do want to find it. V we know is 0. A is going to be gravity. And of course gravity will act down as we're thinking about throwing this ball up. So we got V, U, A and T. So what can we use? Well, V equals U plus AT. So V is 0, U we want to find, minus G times 2.5. So U equals 2.5 G, or 24.5 meters per second. Hopefully that was quite easy to follow there. Now, I think there's more than one way of doing this second part. So this was part A. More than one way of doing the second part. What I'm thinking of is, well, we only want this distance here, don't we? So let's just look at the ball in its final part of the trajectory. So this U, now, because we're not thinking about any air resistance or anything like that, from here to the top, where it gets to 0, yeah, when it goes from 0 back to here, it's going to be going the same speed at this instant as it was at this instant. So if we're heading down, U is 24.5 meters per second going down. T is going to be that 4.5 seconds minus 2.5 seconds. So T is going to be 2 seconds for this section. We don't need to worry about V. S we want to find. And A is gravity. Now, since I'm taking U as pointing down, then my gravity is positive. In this first one, we were looking at it going up, which is why gravity was negative. So we got S, U, A, and T. So you should have guessed this one. This is, of course, S equals UT plus a half AT squared. So we've got 24.5 times 2 plus a half times G times 2 squared. And that gives me 68.6 meters. Now, in terms of alternate methods, I could use this starting one. Shall I do that? You know, I could have used the original, which would give me U equals 24.5. Take up as positive here. We've got A would be minus G, T would be 7, S we'd still be trying to find. S will always be that difference that we've done. You know, so S equals UT plus a half AT squared. So you've got 24.5 times 7 plus a half times minus G times 7 squared. And with this, then you get minus 68.6 meters. Okay, since that's obviously in relation to the start, you can then make a statement that it was 68.6 meters above ground. Okay, now I'm sure there are lots of other methods that you could do here. You know, equally, I could have probably started from the top here. U equals 0, time 4.5 seconds. That would give me that total kind of height here. And then I'd need this height then and take them away. Would then give me this difference in height there. Okay, but like I said, quite a few options here. This is obviously just the way I think. You might have thought a little bit differently. Actually, just go through one final method as I just spotted it here. These are going to be similar triangles. We now know that this is 24.5. If I call this one X, then X over 24.5 has got to be equal to 7 over 2.5. So rearranging this, sorry, let me just rewrite my 7, that's terrible. But yeah, rearranging this, so that's 7 over 2.5 times 24.5, I get 68.6. So that is another way of doing it, okay? Okay, so we've got that this is on essentially a rough plane, isn't it? We've got a smooth, light pulley, so we don't have to worry about anything there. That means that these tensions, they're going to be the same there. Okay, this mass is going to hang down here, 2mg. This one here will be 3mg. Looking at this angle, tan alpha is 3 over 4. That will give me the 5 there. So that means that sine alpha is 3/5, opposite over adjacent, and cos alpha is 4/5. Sorry, first one opposite over hypotenuse and cos is adjacent over hypotenuse. And then let's put on our reaction force here, and that's going to be alpha there. And then of course the mass acting down there will be 2mg sine alpha, and this one in red was 2mg cos alpha there. Hopefully you've got a little bit more room on your diagrams to do this. So let's look at kind of what's happening. If I resolve perpendicular to the plane, we can see that r is equal to 2mg cos alpha, which is 2mg, and cos alpha is 4/5, so 8/5 times mg. That's my value of r there. Now what we want to do is kind of look at resolving parallel to the plane. Now, when I look at this, it tells me that particle A is released and begins to move up the plane. So if that's moving up the plane, that means that I've got friction also acting down the plane, isn't it? Friction will act down the plane. Okay, so we'll look at 4A first. Now, the particle's moving, so we want to look at F equals ma. It's moving up the plane, so T's got to be larger, isn't it? So T minus my 2mg sine alpha and minus my friction, and that equals ma, so that's 2ma. Now, 2mg sine alpha is 3/5, and friction is mu r. Now we know mu is 1/2, and we already worked out r, so we've got 6/5 mg for this first one, and then we've got 1/2 times 8/5 mg for r, and that equals 2ma. And sorry, apologies there, I wrote an equals. Oh, I did that on that one above as well. Should be T minus. So that equals T minus 2mg equals 2ma. Now, at this point, I've actually probably gone quite far. It just says write down an equation for A, so this first one was probably sufficient. Obviously, I've carried on working this out. Let's go for B. Well, again, it's moving, so F equals ma. The 3mg has got to be bigger than T because it's moving this downwards. So we get 3mg minus T equals 3ma. And that's all we've got then for B. Now, part B wants me to find the acceleration. Okay, so what I want to do here is put these two together, which will get rid of my T's, so substitute in for T, and we should be able to get to the A from there. Okay, so let's go from this one, T equals 2ma plus 2mg, and let's substitute it straight into this one. So you can see 3mg minus 2ma plus 2mg was 3ma. So we get 3mg minus 2ma minus 2mg was 3ma. Let's now get rid of these m's as they're in every term, so we can divide through by m. And then we get 3g minus 2g is just 1g. And take the 2ma minus 2ma, I'm going to add 2ma, so it's going to give me, 2a, it's going to be 5a. So A is going to be 1/5 G, or 1.96 meters per second squared. Okay, now part C, before we go any further, let's find our value of T. So we've got 2m, now A is 1/5 G, is 2mg. So 2/5 plus 2 is 12/5 mg. So that's my value of T. And let's have a look at what's happening at the pulley here. So we've got these forces acting up. So if we extend them past, we've got T going that way and T going that way. Okay? And that would mean that the force acting on the pulley is in this direction. Okay? That's the force on the pulley. Now, what we need to do is we need to find the size of the angles here, don't we? So if I think, further down the kind of the line of this is alpha, isn't it? Okay, now what that means is that if I look at these two angles here, they're going to be 90 minus alpha and then divided by 2, because you think of the whole kind of triangle here. So this overall angle here is going to be 90 minus alpha, and it's in half because these are equal in size, aren't they? They're both T, so they're both equal in size. So this angle is going to be that 90 minus alpha over 2. Or if you think of the resultant in the other direction, it's the same thing. That angle there is 90 minus alpha over 2. And then each of my T's is going to be the same, isn't it? T cos 90 minus alpha over 2. So I'm going to have T cos 90 minus alpha over 2. And I'm going to have that twice, so I'm going to have 2 of them. So the force acting on the pulley is going to be 2T cos 90 minus alpha over 2. Now, again, there's a few ways of kind of working this out. So force on pulley, but this is the way I did it. So I know what alpha is. So all I need to do here, just think of any one of my things. So cos alpha equals 4/5. So 4/5 inverse cos of that, and we get 36.9 degrees to 3 significant figures. So 2 minus T cos, this is 90 minus that 36.9 over 2, but use your full value, yeah? So 90 minus the alpha divided by 2, cos of that, which is 26 point something, times by, sorry, just don't know what was going on there, times by 2, times by 12 over 5, and that gives me 4.3 G times by M, which is a bit, mg would be better. Or if I times it by the 9.8, we get 42 M to 2 significant figures, or 42.1 M to 3 significant figures. So totally up to you, kind of there. Either of these answers should be fine. And then final part D. How have we used the information that P is a smooth pulley? Well, it just means that the tensions are the same. So tensions either side of pulley are the same. Or words to that kind of effect. Now, for these types of questions, I like to do a diagram. So let's put the origin in here. The port is -2, 9, isn't it? So say -2, 9. So let's call that our port. And then we've ended up at the point 4, 6. Okay, so this point here. Now we've actually travelled, so if I just draw that one in there, and we've travelled this distance, haven't we? Okay, so this is now where my ship is. And it's at the point, 4i plus 6j. And P is -2i plus 9j. So what I want to think is like, how far have I travelled? Well, from my diagram, it's quite easy to see, isn't it? We've travelled from -2 to 4, so we've travelled 6 across and 3 down. Okay, and this is what I'm going to use. So I'm going to use displacement equals velocity times time. So my displacement here is 6i minus 3j. Then my velocity, which we're trying to find, and the time is, well, it's been 36 minutes out of obviously 60 minutes in an hour there, to keep it into kilometers per hour. So I can just do a little bit of simplifying here, so 36 goes into 60, and that will leave me with 3/5 there. And all I need to do now is basically get V on its own. So I'm going to divide by 3 and times by 5. So that will give me 10i minus 5j. Okay, now as it is given to me in the question, I might actually leave that answer for a little bit step further on down, and maybe I would do 5/3 6i minus 3j equals V, just taking that extra step in between just to show it. Okay, if it didn't give it to me in the question, I wouldn't worry about it, but if it gives it to me in the question, I do want to make sure that I'm being very clear to the examiner that I know what I'm doing. Now, part B says that find the position vector of the ship T hours after leaving port. Okay, so we know where it's leaving port, and we know its speed, don't we? We know its velocity, I should say. It's 10 across, 5 down, isn't it? 10 minus 5. Okay, obviously just very roughly drawn here. So we know this is 10i minus 5j. And it's going to be that multiplied by t, isn't it? For its displacement. So this position here is 10i minus 5j times by t, the time. Okay, but obviously it starts at this place. So the position vector is our minus 2i plus 9j plus t times 10i minus 5j. Remember that this obviously comes as well from the displacement formula, velocity times time. All I want to do here now is just kind of simplify this and keep my i's and my j's together. So for example, I've got 10t minus 2, and that's I. And then in terms of the j, I'm going to put 9 minus 5t j there. So all I'm doing is I just started with a positive value where I could, okay, and just separating out in terms of I and in terms of j. Now for part C, we can see at 8:48, the lighthouse is due east of the ship, yeah? And then at 9 a.m., the lighthouse now is northeast of the ship. So it's worth thinking, so northeast is going to be at 45 degrees there, or 45 degrees there, however you want to kind of think it. Obviously, due east is just directly along the I part. Now, just making a little bit of room here. So 8:48 is, this time is 1 hour 48 minutes, isn't it? So in terms of hours, this is 1.8 hours. So the position of the ship at this point is simply 10 times my 1.8 minus 2i plus 9 minus 5 times 1.8 j. So that's 16i and 0j. Looking at the second one, the time here is 2 hours. So we still got our 10 times 2 minus 2i plus 9 minus 5 times 2j. So this is going to give me 18i minus 1j. So we've got the positions of our ship. So let's think about what's happening. So here's my ship initially at 16i. It then ends up, say here, at 18i minus j, because it's gone across 2 and down 1, hasn't it? Now, at the beginning, I know that my lighthouse had to be on this line somewhere. Yeah? And for me to have a 45-degree angle, which is this one here, wasn't it? 45-degree angle, it has to have the same horizontal and vertical values. So if we've gone down 1, we've got to go essentially up 1 as well, or across 1, I should say, to make sure we get this 45-degree angle in here. Okay, so now when I look at this lighthouse, it's got to be 19i. And the reason is you've gone across 2 and then another 1. Okay, so when you were due east of it here, so it means it had to have just I, no j value. At the second point, so if I do this again just to kind of hopefully make it clear. So the first point, we're at 16i. The lighthouse had to be along here somewhere, some value of I. We then went across 2 down 1, which was the 18i minus j, wasn't it? Across 2, down 1. And then this 45-degree angle back up means that this horizontal has to be 1 as well. So actually the L is here, and we've gone across 2 plus my 1, so we've gone across 3, so it must be 19i, because we've added 3 onto our 16i. Hopefully that's made sense there. Now, we know that the ship has a position vector, 10t minus 2i and 9 minus 5tj. And we know that the lighthouse is at 19i. Okay, it tells me find the position vector of the ship when it is due south of the lighthouse. So if the lighthouse is here, the ship is going to be somewhere below it. They're going to have the same value of I. Okay? But obviously it's got to have some sort of value of J, which is what we're trying to find. But we know it's going to have the same value of I. So if I look at just the I component, 10t minus 2, we know that's got to equal 19. So 10t must equal 21, t equals 2.1. Now I know that, I can work out what my position vector of the ship is. So it's obviously 19i, we know that, plus 9 minus 5 lots of 2.1, j. So it's 19i minus 1.5j. And that is the position vector when the ship is due south of the lighthouse. I hope that's made sense there at the end. I don't think this is a particularly difficult paper, but hopefully you've got enough out of it.